just a multiple of it. There's actually a strange relationship there. So the goal in this problem is, can we find how this is changing? Things like that. If dx dt is positive, x is how far the base is from the wall. If that's a positive number, is dh dt positive or negative? Yeah. So h is pointing upwards, h is getting smaller, the height against the wall is getting smaller as the base moves away. So as this length gets bigger, the other length gets smaller.
How is that possible? I mean, I'm just thinking about Pythagorean theorem. Like if you're changing one,
The rate is based on x. Also, it's not only based on dx dt, it's also based on x.
okay.
We'll see that when we derive it. So the variable, so as x is small, it kind of, it's like multiplying by 0 when you get dh dt. When x is big, now it's making dh dt big.
So it's like the ladder getting shorter.
Nope, ladder always stays the same. That's what makes it interesting. That's where you have to do the calculus. Otherwise, like we have some intuition, but it could easily be wrong. If you do the math, it's not going to lie. But these can break some intuition. Usually, our intuition tells us dh dt would be negative because it's falling down. That length is getting smaller. But we don't really know what it looks like. We just know it's a negative value. All right. So now let's do part 3. Yeah. So we want to answer this one. So, when we get the formula, you'll see why it is, or where that comes in. All right, so we have a 16-foot ladder. And the biggest thing you can do, like sometimes we give you a picture, sometimes we don't. Always draw a picture. And when you draw a picture, you have to choose labels. So I chose X and H. You could do X and Y, it doesn't matter, right? If we ask how fast is this moving, at the end you get a number, circle it, that's your answer. It doesn't really matter what letters you use for anything. What are we, so our goal is what? So we know it's moving away at 3 feet per second. So this is going this direction at 3 feet per second. And I want to find the velocity of the top of the ladder at time t equals 1. And there's one other thing I know at time equals 0. X is 5 feet. I left that up. So I always want to write this in the notation of calculus. What do we know? We're given some information here. What are we given? If this is moving at 3 feet per second, what does that mean in terms of derivatives?
So
dx dt must be 3 feet per second. The rate of change of x. So all variables depend on time, right? Base of the ladder is moving, that distance depends on time. If the top of the ladder is falling down the wall, that height depends on time. You have time starting at one point, and then as you move forward, this has changed, everything kind of depends on time in the background. When we say the word rate, it really means like a velocity or something depending on time. Rate of change with respect to time for all these problems. All right, so that's moving at 3 feet per second. What else are we given? know the hypotenuse, at time x equals 0, or time t equals 0. So x depends on time, right? Like x depends on time, h depends on time. So x of 0 must be 5 feet. And we know the hypotenuse is fixed. So what are we trying to find? dh dt, the velocity, the height, when t is equal to 1 second. So like this keeps changing. What happens after 1 second? So this was that notation we mentioned the other day. What does this bar mean? So we know dh dt depends on time, right? H is a function of time. This rate also depends on time. This says find the rate and then plug in t equal 1. All right, anytime you write a bar that says something like this, it means plug in this value in the end. Or the other thing you could say, this is the same as finding h prime of 1, where the prime is derivative with respect to t. T is our independent variable. All right. So this is where we're headed. The biggest question you always have to answer is how are the variables related to each other? I have a variable x and a variable h. How are they related?
One's the sine, one's the cosine.
You could say that, but that assumes you know an angle.
Oh,
So we go above that.
it's like a tilted house.
So this is a right triangle, right? And I know the hypotenuse. I can relate the hypotenuse to the legs. This one's a leg, this one's a leg. So I can do Pythagorean theorem. X squared plus h squared must be the right hypotenuse squared. Alright. So this is my primary equation. This relates x and h. I know something about the rate for x. I want to know something about the rate for h. How can I do that?
Find the
I
derivative.
know how they're related. Now I want to know how are the rates related to each other. So I need to find rates, right? How do you do that? How do I get a dx dt to show up?
We find the derivative of each.
Find the derivative of both sides. That is what implicit, or we use implicit differentiation. We say take the derivative of this side and the derivative of this side with respect to time. This will give me a dx dt to show up. I want this rate to show up. I have an x sitting here. When I take the derivative, I'll get a dx dt. So what do I get when I do this? What is the derivative of x squared? 2x dx dt. Power rule says bring 2 down, subtract 1, so I get 2 times x. But x depends on t. I was taking the derivative with respect to t. So the chain rule says treat x of t like an inside function. So I didn't need to multiply by its derivative. So I'm reading that as find the derivative of x of t all squared. So the derivative would be 2x of t times the derivative of the inside is x prime of t. This notation would be awful, these primes everywhere. Instead, we drop all the t's out and just say 2x dx of t. Like we know this depends on time, but we don't always want to write up t everywhere because it would just make it down the road to read. What's the derivative of h squared? H, what's the derivative of 16 squared? 0. So my goal is to find dh dt, right? I have a dh dt sitting there, I can solve for it. So 2h dh dt is equal to negative 2x dx dt. So dh dt is negative 2x over 2h dx dt. Divide everything by 2h. Now I have that by itself. Anything cancel? I guess the 2's. So my other equation would be dh dt, this rate must be negative x divided by h dx dt. So now I have two relationships. I know x and h are related this way, and now I know their rates are also related in this way. I mean, I could have boxed this one. This relates to rates. The reason I solved for dh dt was our goal was find dh dt. Going back to our original question. If dx dt is constant, why was dh dt not constant? When the base was moving at a fixed speed when I was showing the animation, how come this was really slow and then really fast? What happens when you're at the top? X is 0. So what would this rate be at the very top? When x is 0, this is basically 0. Or when x is small, this is small. Doesn't if this is just a number. What about at the very end when suddenly the top fell really fast once I was near the ground? What happens there? That's when h goes to 0. What happens when you do x over 0? It's like you get a vertical asymptote, it goes to plus infinity. Suddenly the rate's jumping up to infinity, that's why it was so fast there at the end. It's going from barely changing to changing instantaneously fast. So that matches the animation. Why was it not just a direct correspondence? Because it had this x divided by h sitting there. The rate depends on x and h at the same time. As x and h change, the rate changes. Alright. Now what do I need to do? This is where you have to now be creative. Usually we ask the problem, we say something like, find it when x is equal to 6. Which would be much more convenient because I can then plug in x equals 6. We said, find what happens after 1 second. Do I know? So think about what we're given. I can plug in 3 for dx dt, right? Do I know what to plug in for x over h? I need to know a number for x, I need to know a number for h, right? Do I know either of them? We almost know x. If we know x, can we find h? I boxed this because this tells us if I know one, I can find the other. So once I know x, I can find h. How can I find x? Just like it. This is what makes word problems hard. We know how to do 90% of it, and then we hit some wall on there's some value we don't know. And 90% of it's not good. We end up spending 3 times longer trying to figure out what to do in that last 10%. The reason I want to talk about this one, this is a little bit more challenging, but it's one that shows up sometimes. In the homework, they actually give you easier problems than this for the latter type stuff. Yes?
X at 1 second is p8 3.
So, what does it mean if, so I know x of 0 is 5. I'm going to go through the long explanation. What does it mean if you have a constant rate of change? That means your slope never changes, right? What kind of function do you have if your slope never changes? Must be a line. So x of t is a line. My variable is time. It must have some fixed slope and some y-intercept. What's the slope? Feet per second. The x dt is 3. That means x prime of t is 3. The slope must be 3. The 3 never changes. What's the y-intercept? How do you get a y-intercept? Plug in x equals 0. So plug in. That's actually what this is saying. What happens if I plug in 0 here for time? That part goes away. So I must get b is equal to 5. At time t equals 0, I know x is 5. What we really gave you was a y-intercept. We just didn't write it that way. You always know more than you realize. So x of t for any time must be this. If I plug in 0, I get 5. Now what happens at 1? We want to know what happens at time t equal 1. So I could plug in 1, right? X of 1 must equal 3 times 1 plus 5. So I get 8. Which is what you had said. You did all this in your head and no idea you were doing it this way. Awesome. Why would that make sense? I'm starting at 5 and I'm moving 3 feet in 1 second. That's what the slope says, right? My slope is 3 feet per second. If I'm moving at 3 feet per second, how far do I move during 1 second? 3 feet. If I start at 5 and I go for 1 second, I move 3 feet. So I must have moved 8 feet total. You could have just said x of 1 is 8. I would have been cool with that. I want to talk about why that's actually stuff we know, or this is the formal approach. To kind of bridge some of those concepts. Anytime you see the word constant rate, it means that variable is really the equation of that variable, the formula for that variable must be a line. If it's a line, it just means slope y-intercept. You're usually given some point. So if you're given a point, you do slope point formula. Alright, so I know x of 1 is 8. How do I get h of 1? So to use this formula at time t equal 1, I need to know what is x of 1, what is h of 1. How do I go back and get 8? The original formula says give me an x value. X squared plus h squared must be 16. If I know an x value, I can find an h value. So going up to here, 8 squared plus h squared must be 16 squared. So h squared is 16 squared minus 8 squared. Which is what? 192. And so h is the square root of 192. Is that a nice number? Okay. Good enough. We allow calculators now. For years we never allowed calculators, which meant this would be square root of 192. That's a number. We're good. Alright, so I know h of 1 is 192, or square root of 192. So I know x of 1, I know h of 1, and I know dx dt is always 3. So what does that tell me? My goal was dh dt, when t is equal to 1, that must be negative x of 1 divided by h of 1 times dh dt. So I get what? Negative 8 divided by the square root of 192 times 3. So negative 24 over root 192. What would be the units? Feet per second. H is measured in feet, time is measured in second. I'm dividing here, feet per second. Am I allowed to leave the square root in the bottom? I don't know why they ever told people in high school don't do that. Divide by square root, it's a number. Please don't go, they rationalize and do everything else. There's no need for any of that, this is a number. Do I need to plug in my calculator and tell me 10 decimal points? Nope, that's enough.